This is a video with regards to a question in the group of questions in the central limit theorem assignment with regards to sample means. So it says the average production cost of major movies is $58 million. So what I've done here is I have typed that number 58 in for mu. And it goes on to say that the standard deviation of that population is 19. So I typed 19 in here for sigma. Assume the production cost distribution is normal, and suppose that 48 randomly selected major movies are researched. So that means our N is 48. Answer the following questions. Give your answers in millions of dollars, not dollars. And round all your answers to 4 decimal places where possible. So in question A, it just says, what is the distribution of X? Capital X is just the population. And that notation there is just saying, okay, we know it's normal or approximately normal. The first blank is asking you to identify its mean, and the second blank is asking you to identify its standard deviation. So I put that notation right here off to the side with an arrow drawn to part A. So in A, we would identify that the mean is the 58 given. So I'm going to say equals, and then click on that cell that contains 58. I could certainly just type the number 58 as well. And then I also need a second answer there, which is asking for the standard deviation. So it is the population we're talking about here in A. So we'll just say equals that population standard deviation of 19. Again, I said equals and pointed to the cell. You could certainly have just typed that number in here as well. But B is asking about the sampling distribution because it says, what is the distribution of X bar? So if you were to take every single possible sample of size 48 from this population, calculating mean, what does the distribution of all of those possible means look like? Well, it's going to be approximately normal because the population is normal, but also the central limit theorem teaches us that whenever your sample size is at least 30, then you can assume your sampling distribution is approximately normal, even when the population isn't. So the mean is going to be the same as the population mean, still going to be that 58. But the standard deviation you see over here for the sampling distribution, as your sample size increases, the standard deviation or amount of variability in your means decreases. And that's because you're dividing by a bigger number. So we have to calculate what sigma over square root n would be equal to. So I'm going to type equals sigma divided by, and then square root. If you just start typing SQ, you see that it's the RT, open paren, and then it says, what number do you want me to give the square root of? Well, we want the square root of n. So I'm going to click on that cell that contains n and close my parentheses. Now notice, though, that that's not rounded to 4 digits after the decimal point, and the instructions are telling you to do so. So over here, I'm going to round to 4 digits after the decimal point. To do that, I'll just do R equals ROUND. Now I could just keep typing it and put the open paren, or I can double click on round. And it tells me exactly what I need to put in for this command. It needs the number. What number am I rounding? Well, I'm numbering this number right there. So I click on the cell, comma, how many digits do you want me to round to? And our instructions in this problem say 4. So I'm going to close my parentheses and hit enter. And now you notice it's just taken the 2.742414 whatever else and rounding it to just 4 digits after the decimal point. Good. So now we're ready to do some calculations. In C, for a single randomly selected movie, that means we're selecting one from the population. Find the probability that this movie's production cost is between $56 and $58 million. So we're finding the area under a normal curve between 2 values. You can find the area under a normal curve below one value by using the norm.dist command. So you can use the norm.dist command twice to determine the probability or the proportion that are going to be between these two values. And here's how we do this. For my answer to C, I'm going to use the norm.dist command, and I'm going to take the bigger, find the area below the bigger of the two values, which is $58 million, and subtract the area below the $56 million. That'll give me the area in between. So I'll type equals norm.dist, open paren, or I could have double clicked. It says, all right, what do you want me to find the area below? That's your X. So I'm going to click on the bigger of the two, comma. What is the mean? Well, it's the same as the population mean, 58, comma. What is the standard deviation? Since we're selecting only one, it's the same as the standard deviation of the population. So we're going to use our standard deviation from part A, comma. And then it's saying, do you want me to find the cumulative area below that? Most certainly. So we'll say true. Close your paren. And I'll hit enter, and that's telling me that the area below 58 is equal to 0.5. Well, duh, 58 is the mean. That's duh for me. 58 is the mean, and the area below the mean is always equal to 0.5 or 50%. Now I'm going to do the same thing a second time and find the area below the lower of the two values. So I'm going to do equal norm. This time I'll double click just to show you when you do so, it gives you the open paren. What do we want the area below? Well, 56, comma. What is the mean? Still 58, comma. What is the standard deviation? It's still 19, comma. And do you want me to find the cumulative area below? Absolutely, true. Enter. So the area below the lower dollar amount is 0.458-ish. We need to take the area below the bigger and subtract the area below the smaller. So equals area below the bigger minus area below the smaller. And if you round that to 4 decimal places, hopefully you can do that in your head, it's 0.0419. But just to be safe, it's equals round this number, comma, to 4 digits after the decimal point. There's your answer for C. Okay, so final answer here for C is that. Had to do some work to get there. So now finally in D. In D, we're not taking a sample of 1. We're taking a sample of 48. Therefore, and we're calculating a mean, and we're wanting to know the probability that the mean will be between 58 and 56, or 56 and 58. So we're going to be using our values from B. The mean isn't changing, but the standard deviation certainly did. So I know again, because 58 is at the mean, the area below is 0.5. I don't need to bother with that whole norm.dist command. The area below the mean in a normal distribution is always 0.5. But to get the area below 56, I'll need my norm.dist command. So I'll type equals norm, double click dist. I want the area below 56, comma, the mean from part B, which is the same as the mean from part A, comma, and the rounded standard deviation from part B, which is this cell here. And then yes, I want the area below. The area below 56 in this less spread out sampling distribution is less. So now we want the difference in those areas. So equals bigger area minus smaller area. And if we can't round that in our head, equals round this number to 4 decimal digits after the decimal point. And our final answer, you see, is bigger because that interval from 56 to 58 is a greater number of standard deviations in the sampling distribution than it is in the population distribution. Let me know if you have any questions.